All right, good morning, Spartan fans. We're going to look at section 11.6 today, which is the last section of notes before your test, which is next week. The sub should have given you a note sheet. So we're going to look at solving systems of nonlinear equations, which means not lines. And there are three different ways that we can solve a system of equations, just like we did for lines. So we could graph to find the intersection point using Desmos. And there could be more than one intersection. And I'll show you an example of what that might look like. And then we're going to talk about substitution. And we're going to talk about elimination. Okay, so non-linear. That could be a parabola. A parabola is non-linear. Parabola could intersect with, let's say, a circle. And that would have, two intersection points. Or you could have two parabolas that intersect, and maybe one of them opens up and the other one opens down. That could be a system of nonlinear equations. You could have a parabola, one of them opens facing up, and the other one opens facing to the right. So there's all kinds of different ways that systems of nonlinear equations could intersect. All right, so let's look at this first example. There are multiple ways you could do it. The directions say substitution, so that's how I'm going to go about it. So substitution means to isolate one of the variables and then substitute it into the equation. So we're going to isolate x or y, and we're going to use either, I'm going to number them, equation 1 or equation 2. Okay, options. You could, if you wanted to, in the first equation, isolate y, and you could say that 3x plus 2 is equal to y. That's an option. You could, if you wanted to, you could isolate x, and you could say that 3x equals y minus 2, and then divide both sides by 3. So that's kind of gross because it involves fractions, so I am not going to do this second option. Or I could use the second equation, and I could isolate y, and I could say that y is equal to 2x squared. So it doesn't matter which way you do it. I would not use the option of isolating x because it involves a fraction, and who wants to substitute using fractions? So I think I'm going to use my second method, and I'm going to say that y is 2x squared. And so in the first equation, I'm going to take y out, and I'm going to put 2x squared in. So now I'm going to say 3x minus y, which is now 2x squared, is going to equal to negative 2. And now this is a quadratic. So I'm going to add 2x squared to both sides, subtract 3x, subtract 2, and then I'm going to factor and use the zero product property. This is going to be 2 minus. Let me just do a quick double check, make sure I did it right. 2x squared minus 4. Yeah, looks good. So when you use the zero product property, you're going to get x equals negative 1/2 and x equals 2. So now that you have solved for x, I'm going to go back in and I'm going to solve for y. So I'm going to do 2 more substitutions. I'm going to substitute that x is negative 1/2, and I'm going to substitute that x is 2. Okay, so if x is 1/2, so it's going to be 2 times negative 1/2 squared equals y. And so let's see, that's 1/4. This is going to be 1/2. And if x is equal to 2, that's going to be 2 times 2 squared. Watch out for your order operations. That is not 4 squared. It's 2 times 2 squared, which is 8. Okay, your final answer must be ordered pairs. You need to indicate which x goes with which y. So when x was negative 1/2, y was positive 1/2, and when x was 2, y was 8. Okay, that is the substitution method. You would have gotten the exact same answer if you would have substituted y equals 3x plus 2. Either way makes no difference. Okay, elimination, which I find is the preferred method of choice for most people. So elimination means you need to either add or subtract the equations together and eliminate a variable. Who cares? Eliminate x, eliminate y, it doesn't matter. So let's just see what happens if I add these together. X squared plus x squared is 2x squared. And then be careful here, y squared and y are not like terms. So when you add those together, you get plus y squared minus y equals 6. That is not helpful. I have too many variables. I have an x and I have a y, not going to help me. Okay, so let's try subtracting instead. Be careful when you subtract. I highly recommend using parentheses. When you subtract, x squared minus x squared is 0. Fantastic, I've eliminated. And then I'm going to get y squared minus negative y. Be careful, that becomes plus y. And when you do 13 minus negative 7, negative becomes positive. So this is now 13 plus 7, which is 20. And it has been a long time since I've told you this, but your factoring life never goes away. It's a quadratic, set it equal to 0, factor and solve. Okay, so y is negative 5 and 4. And now I'm going to go back in. So I'm going to say y is negative 5. I can plug into the first equation. I can plug into the second equation. I'm going to use the second equation. It looks to me like it's a little bit less complicated because there's not so many squared variables. So I'm going to start with y is negative 5. So it's going to be x squared minus negative 5, and that's going to equal negative 7. So you get x squared equals negative 12, and that's not possible. So negative 5 is not a viable answer for y. So that would be imaginary. You can't square a number and get a negative solution. And then I'm going to say y is 4. See what happens here. So if y is 4, I get x squared minus 4 equals negative 7. You get x squared equals negative 11. Also not a viable solution. So the answer to this problem is no solution. I always get nervous when I make these videos. It seems strange to me that the answer is no solution, so I'm hopeful that I didn't make a careless mistake along the way that I can't catch. So I'm going to take a minute here to figure it out, just to make sure. So I subtracted y squared, that becomes plus y, 20. I subtracted 20. I factored it, plugged in here, y minus negative 5 plus 5, so subtract. And then minus 4, add 4. So I did make a mistake, but it still ends up being no solution. This is, instead of being negative 11, it ends up being negative 3, but it is still no solution. X squared plus y squared equals 13. This is a circle. And x squared minus y equals -7. This is a parabola. This is a parabola that opens right side up. So here's how this could potentially look. It could be a circle, and the parabola opens outside of the circle. That is most likely what this looks like. All right, last one, we're going to figure out which method works best. You have choices, so on your test, I will allow you to choose whichever method you like better. Sometimes it's hard to determine which one's better. So substitution. I'm going to use, for substitution, it's nice because this first equation, y is already isolated. So I don't really have to do any extra work. So I'm going to take y equals x squared plus 3, and I'm going to plug it into the second equation, and be super careful here. So it's going to be x squared plus y, which is now x squared plus 3, squared equals 9. This is not x to the 4th plus 9. That is voodoo math. No, 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 no. So I'm going to write this out as x squared. And then I think for many of you, write it out as x squared plus 3 times x squared plus 3. That'll help you make less mistakes. So this ends up being x to the 4th plus 6x squared plus 9. Combined like terms. Set it equal to 0, factor and solve. So when you set this equal to 0, which is great, and now don't forget GCF, when you factor, it's always the first step. So I'm going to take out an x squared, and that's going to leave me with x squared plus 7, 0 product property, x squared equals 0, so x equals 0, x squared plus 7 equals 0, x squared equals -7, and that's not a viable solution, so x would be 0. Okay, and now I'm going to plug back in. So if x is 0, I'm going to plug back in up here. So if x is 0, y is 3. Okay, that's substitution. We should get the exact same answer using elimination. So elimination, you should add or subtract two equations together and try to eliminate a variable. The problem with this equation, or this system set up the way it is, the variables aren't lined up. So if you just tried to add these, you should have like the y's on top of the y's, the x's on top of the x's, and then in addition, the equal signs aren't lined up. So what I'm going to do is I'm going to alter this first equation, and I'm going to subtract x squared from both sides. Now my x squareds line up, my equal signs line up, and we should get the exact same answer using elimination. So now when I add these together, x squared, negative x squared plus x squared is gone. Okay, and then note that y squared and y, those are not like terms. Okay, so I'm going to get y squared, and I'm going to subtract 12, and lo and behold, we need to factor again. So y is -4, and y is 3. Okay, great. And now I'm going to substitute back into either equation, so you could plug into the first equation, or you could plug into the second equation. I'm going to plug into the first equation. It does not matter which one you choose. So I'm going to plug in -4. So I'm going to plug in -4 for y. And so I'm going to get -4 equals x squared plus 3. Subtract 3. Oh, look familiar? Same thing we got in the previous. X squared is negative 7. X squared is negative 7. No can do. And then if if y is 3, so again, I'm going to plug in right here. If y is 3, you get x squared is 0, x is 0. X is 0, y is 3. Same answer either way. You get to choose which way you like better. All the information that you need for the rest of class and for the upcoming test is on Google Classroom.